So till block diagram we have already studied in the last class. So what we have here is, I told you that every interfacing IC will be having something which is called control register inside, CR. Fine. So today we'll study about the control register. The control registers are basically of two types, or you can say there are two configurations of control register. Fine. So let's see what is inside 8255. So this is the format of the control register. You can see. Is this thing visible to all of you? I guess.
Yes, sir.
That's input output mode.
Yes, sir.
The important stuff is about the configuration, in which configuration your control register is in right now. There are two configurations. Slowly I'll let you know about everything. But what you are watching right now on the screen is an 8-bit register mentioning D0 to D7, and every respective bit has something to do. Okay, so how to start with this and how to deal with this, let me tell you in the slide. So basically what we have is an 8-bit register. We'll be doing the programming of this in the form of placing few bits inside. Okay, so what happens is, we have control register, and control register basically will be having two configurations. One is called input output mode and other is called BSR mode. And I know this is really it must not be getting into your head right now, but just keep calm for next 15 minutes, everything will be clear. Okay, so CR is your control register and it has two configurations like input output mode and BSR mode. So what basically a control register is just an empty register. It's just an empty register with an 8-bit placement of the bits, but every bit has a significant purpose. So if I talk about input output mode, fine, and the trick is always start the consideration of this control register from D7. Always start the consideration from the D7, because D7 is like a switch between input output mode and the BSR mode, right? So what happens here, if I put D7 is equal to 1, the control register will switch itself into input output mode. But if it puts, or if you put 0 in the D7, then the control register will be switched into the BSR mode. Fine. And after switching in input output mode or BSR mode, the next 7 bits D6 to D0 or D0 to D6, they all will have a changed configuration. Fine. So in order to see what is the selection, I'll tell you how to select for input output, how to select for BSR, what you need to see in the problem. Fine. So everything starts from D7. If D7 is 1, the mode will be input output. If D7 is 0, that will be BSR mode. Fine. So let's talk about input output mode. That means D7 is 1 in this case. Fine. Now let's get back to this figure. See what we have here. We have 8 bits, out of which 1 is with prefix. That input for input output mode, D7 will be 1. Okay, so that will be your 1 always for this particular mode. So let's start with the rest of the 7 bits starting from D0, D1, D2. These 3 bits belong to group B. I've already told you that in 8255 there are basically 2 groups, group A and group B. A means port A plus port C upper, B means port B plus port C lower. This is how this thing is created in 8255 grouping category. Alright, so D0, D1, D2 they belong to group B, and after that D3 to D6 they belong to group A. Fine. And they even follow the same pattern. Now, what is the pattern? Let me tell you. At D0, D0 is your port C lower. Port C lower is what? It is a minor port of group B. Fine. So first is minor port, then major port, then mode. Fine. Same phenomena we are having at D3. Check out D3. At D3 we are having port C upper. Port C upper is what? It is a minor port. Next we have D4. D4 port A, which is major port, and next is the mode. Fine. Group A is having a one more mode than the group B. So this is how the sequence will follow. First minor port, then major port, and then mode of selection. Fine. So let's get into the detail. So D0 is for setting port C lower input or output. If you want port C lower to act in any configuration, suppose you want to set it in input configuration, you want to set port C port as input. So just place 1, and if you want to convert it into the 0, just place 0. Okay. Likewise, for all the ports in the configuration of 8255, 1 is for input and 0 is for output. By this 0 and O, 0 and O, you can remember this thing that 0 and O, 0 and O is for output. Other one is for input. That's it. Fine. So port C, 1 for input, 0 for output at D0. D1 port B, 1 for input, 0 for output at D1. D2 is for mode selection. That will be given to you that which mode is to be selected, or it will be highlighted somewhere, or you need to understand that which mode is to be applied. Alright, now group B, look at the group B, there are only two modes we are having here, but on the contrary, in group A, there are 3 modes we are having. Mode 0, mode 1 and mode 2. This mode 2, this is very complicated. This is called bidirectional mode. Bidirectional mode. Bidirectional mode. Okay, so that is only possible with the group A. It is not possible with the group B. Fine, but that too is a very complicated situation of having a bidirectional data transfer or kind of communication. So let's get back to D3. D3 is again port C upper, minimum minor port, 1 for input, 0 for output. D4 port A, major port, 1 for input, 0 for output. Same thing, mode selection. Now we have one more mode, so that means we are having 2 bits to store, D5 and D6. So whatever the condition you are having, just place the bits respectively and you will get the answer of what we have to design. Okay, is that clear? It will be more clear the moment I'll be giving you the problem, because this is only the framework you are studying. The moment I'll be giving you the exact problem, you need to remember this configuration. You have to keep this configuration in front of your eyes, then only you could be able to program. Alright, so now come to the second configuration, which is the BSR mode. BSR stands for bit set reset. Bit set and reset, but which bit to set and which to reset? This is the question somebody should ask, sir. Which bit are we going to set and which bit are we going to reset? Alright, so the answer is, in the BSR mode, the answer is only port C, no other port. Only port C bits will be considered for BSR. BSR only works with the bits of port C. Okay, so whatever the selection we'll be doing here, the selection will be of port C bits, nothing else. Okay, so thumb rule again, always start from the D7. Now in this case BSR, so that means your D7 will be 0, like this. Okay, next 3 bits D6, D5 and D4, they are basically don't care bits, so just you can simply place 0, 0, 0 in them and they are of no use. But next D1, D2, D3, they are the bit selection bits. Now which port are we going to select? We are going to select port C. So these bits are giving you the selection of the port C bits, like 0 is PC0, PC1, PC2, and it will be till PC7. Fine. So what's going to happen? Suppose I'm asking you to set PC1. So what will be the configuration? How can I select? First thing is selection, then we'll see for setting or resetting. So first is to select PC1. PC1 is where? PC0, PC1. This is PC1. So the configuration what we have here is D1 will be having 1, D2 will be having 0, and D3 again will be having 0. It's like 1 0 0. By loading this, we'll be able to select PC1. And next, D0 is responsible for setting and resetting. Fine, very simple. 1 to set and 0 to reset. If you want to set, just place 1. If you want to reset, just place 0. Simple. Fine. So you can select the bit pattern from this table, and you can just put 1 in D0 for setting and 0 for resetting. That's simple. Nothing else. Fine. So bit set reset, I repeat, is only for port C. It's not related with port A or port B. It's only for resetting and setting the bits. Fine. But on other case, the input output mode is full-fledged mode which will give us the configuration, or it can provide us the ways we can program the 8255. Fine. So let's do a problem in order to understand in a better way. In order to understand this in a better way, write down configure. Now right from the next line, port A as input port, configure port A as input port, port B as output port, port C lower as input port, and port C upper as output port. So what this is the problem which has been given to us, and let's say the mode is 0 for both group A as well as the group B. Fine. So in that case, how are we going to attempt? How are we going to proceed? Now see, what you have to do is just draw an empty register like this and divide it into the 8 sections. Divide it into the 8 sections like it is an 8-bit register. Label with the D0, D1, D2, D3, this is very important, D5, D6 and D7. Fine, so this is an 8-bit register which is empty. So right now tell me, which configuration are we going to use? Input output or BSR? What can we identify from this problem which is given to us? Input output or BSR? Tell me.
Input output.
What should I put at D7? 1 or 0?
1.
1. Why so? What could be the best reason? Because the configuration says input output only. Fine. And what we are talking about in the problem is input output, input output. Are we talking about set and reset? No. We are talking about setting something to input and output. There's nothing to get confused. Okay. So let's look at the problem. We are having input output in the problem. That's why D7 will be 1 and the control register configuration will be your input output configuration. Fine. So what was the input output configuration? If you have not drawn, let me show you again. Fine. Now keeping in mind this configuration, and this is the problem you are having, tell me what will be the answer. Quick. What will be the answer? Quick. What will be the bit pattern we'll be having? Quick. Anyone? Anyone?
So just a minute, please.
Just a minute. No. This is not going to take that much of time. Okay, if you are still not able to complete it, now get back to screen. I'll tell you. So what is D0? What should be here at the D0? D0, D1, D2, they all belong to group B. What is the configuration? Minor port, major port, then mode. So D0 is the minor port of group B. What is the minor port of group B? Port C lower. So what has given as the configuration of port C lower is input. Input means 1. Major port of port B, group B, port B. Port B is given as output, that means 0.
0.
Mode, what mode is given? 0. D3, D4, D5, D6, they belong to group A. Fine. First one is minor port. Minor port is port C upper, output 0. Major port, port A, input mode 0. So what answer are we having here? For that, convert this binary pattern into the BCD number. So 1001 becomes 9 and 0001 becomes 1. So what answer are we having here is 91H is the code. This is not a random number, or it is not an arbitrary value. This is a code. For anyone it could be anything, but for you it is code. What it will be doing, after loading this value inside 8255, inside the control register of 8255, what it will do, it will set port A in input, port B in output, port C lower in input, and port C upper is output. See, this is the beauty of assembly language. You can actually do not understand anything until and unless you know about it. If you know about the 8255's configuration, then only you can decode what is 91H. Otherwise, you will never be able to. अगर आपको ये syntax नहीं पता है, what is the syntax we are having for bit pattern and control register, you will never be able to identify what this 91H means. Okay, so my next concept for you to understand is, now what we have calculated a value which can set or reset the configuration, or according to the required configuration we created almost a code. The code is 91H, but right now 91H is lying in your notebook. It is written in your notebook or on this screen right now. You can see this thing is simply lying in your notebook or on this screen. But my objective is what? My objective is to load this value inside 8255, and inside 8255 there is a place called CR. CR stands for control register. Okay, so this is the place where this value should be loading. This 91H should be loading into the CR, control register of 8255. But right now it is in your notebook question, or whatever the way you are writing. Right now it is on my screen also. How this value will go inside? Can anyone tell me? How this value will go inside 8255? Quick. We've already started handshaking. You take a guess from that, please. Anyone? Anyone? Seems like you guys have forgotten, but we studied in handshaking. On the left side of 8255, when we were studying handshaking, everything was coming from microprocessor. There was a data bus, and by data bus, the processor and 8255 was connected. And I told you, interfacing ICs doesn't have their own thinking capability. They can't generate this code by themselves. Fine, they do not have any ALU or any other decision making circuitry. What should we hear, 0 or 1? So somebody has to provide this command to 8255, and who can do that? Only the microprocessor can do that. It will load this 91H via data lines inside the 8255. Okay, and 8255 can further interact with the peripherals via ports. So what this will do, inside 91H has a configuration like A acting as input, B acting as output, likewise for port C and port C upper and lower. Now, as soon as it sets inside the control register of 8255, they all will be configured according to the configuration which is prescribed or it was decoded earlier. Fine, understood? Is that understood?
Yes, sir.
Okay, so this is how the 8255 communication establishes in microprocessor domain. Fine. So I was giving you only the configuration of the control register. In the next class, we'll study about the modes and port address designing, port map designing also. These are two very important topics. Fine. And yes, it will take two more lectures to finish it to 5.5. After that, every IC will have the same approach, like 8254, 8279, 5951. They all will have the common approach. There will be a control register. We have to write program according to it, load the value inside, and see the operation according to the problem. So that will be very easy for you to understand. The first one will be always not easy to take. Before I start with the port map design and address design, you need to understand few concepts. Okay, so what concepts I want you to understand first is, suppose this is the motherboard that we are, let's say we are going to create or we are going to design. Fine, and this motherboard contains a lot of components on it. It contains lots of components on it. What happens is, it will be containing a microprocessor and it will be containing a lot more other ICs also, and they are very well connected to each other. You might have seen somewhere like these, there are lines, there are few more components, there are ports like your USB port or VGA port or HDMI port. There are many ports like this, and they all are connected. Fine. So what I want to say, just note my statement. Every digital component, not a solid state component, a digital component connected in the motherboard or in the circuit will have a valid physical verified port address. What this means is, every component that is connected in this motherboard, every component, let it be this, let it be this, a digital component, something which is having a digital form, having 0101 in it. Fine. What they all will be having? They all will be having the port addresses in it. Fine. So processor wants to communicate to any of the device. So how processor is going to communicate without the address? Fine. So every communication point, let it be any device in the motherboard, the processor knows the address of each and every. Okay, processor wants to communicate to anyone, so the processor needs to know the address. प्रोसेसर को एड्रेस पता होगा तभी तो वो उस जगह पे कम्युनिकेट कर पाएगा. Fine. And how the port address will be generated, how this port address will be designed, that is the job of the hardware designer. That is the job of hardware designer. So how they do the port address designing in this circuit, how they do create that circuit. This is what we are going to study today. So what you need to understand is every digital component which is connected in a motherboard will be having a port address which is valid, physical and verified. I'll show you what these three words are. Fine. So I'm taking the example of 8255 to start with. Okay, so what 8255 is having, 8255 is having three ports: port A, port B and port C. Port A, port B, port C. Okay, on the left side, what pins I require? I require only very few pins. So first I need a CS bar, then selection lines A1, A0, then read write, then reset. So the whole structure is like this. Okay, so how we are going to do that is, for that port map designing or port address designing, what I need is we need to connect 8255 to the circuit so that processor can access. So in order to select 8255, there is only one way by which we can do the selection of 8255. So and that is possible only by CS bar, because CS bar stands for chip select. Fine. And if you want to select 8255, the CS bar should be 0. That means it must be having a 0 as its input because it is active low. Then only 8255 will get selected. Otherwise it won't be selected. So for selection of 8255, the CS bar should be 0. Okay, and this is the whole key concept we are having here. So what I'll be doing is I'll be breaking the signal of CS bar, and by a phenomena of doing something from the digital electronics, I'll be creating a port address map. Okay, so let's see what I'm going to do. Let's say I connect which gate is this? Can anyone tell me? This is which gate?
AND gate.
This is NAND gate. And how many inputs are you seeing this NAND gate? This NAND gate is having 1, 2, 3, 4, 5, 6 inputs. Fine. So let me give the numbers to these lines also. So in continuation with this A0, A1, let us say this is A2, A3, A4, A5, A6 and A7. A7. Okay, so what my ultimate objective is, so you can see here A2 is having, this is what, this is a NOT gate. This is a NOT gate. A4 is also having a NOT gate. A6 is also having a NOT gate. A7, A5, A3, they are directly connected to this NAND gate. So this is a 6 input NAND gate you are seeing here. Okay. So what should be the objective here? What should be the objective here? The objective here is the output of the NAND gate. The output of the NAND gate should be 0. The output we know already, the outputs of the NAND gate should be 0. This is what we need to keep in mind always, that this gate should provide us a 0 output. So when it will be giving us the 0 output, can anyone tell me what will be the values of A2, A3, A4, A5, A6 and A7 in order to get a 0 output? Can anyone tell me what are the values on A2, A3, A4, A5, A6, A7 in order to get a 0 in the output?
सर जितने नॉट वाले उनमें जीरो जाएगा और जितने नॉर्मल वाले
Wait. Write it down in a sequence. How to write it down? Just write it down in that form. Write A2, A3, A5, A6, A7. Write it like this. And here, write all the values, whatever it is.
सर 101010.
Okay, we'll see that. Okay then, so in order to get 0 in the output of the NAND gate, this is your NAND gate. What should we add? A7. Can anyone tell me what should be the A7? How many of you are not able to get it? That output should be 0. In order to get output at output 0, what should be the input? How many of you are not getting? कितने लोग इसको नहीं कर पा रहे हैं? This comes from digital only. NAND गेट का आउटपुट 0 चाहिए तो इनपुट्स क्या होंगे? I want the NAND output should be 0. Okay. So what should be the inputs?
तो सारे इनपुट 1 होने चाहिए.
Okay, you better. ठीक है. Anyone else? Okay then. In order to get a 0 in the output of NAND gate, like someone has already replied, all the inputs that are just connected to the this NAND gate, they should be 1. Okay, because it is more of like a multi-input NOT gate here. Okay, so in order to get 0, all of them should be 1, but here only. This also 1, this should also be 1, and this should also be 1. Okay, but here we have already connected a NOT gate. So in order to get output of 1 from NOT gate, it should be 0 here. This is as it is, it is 0. It is as it is 0. Then it is as it is. Fine. So now what pattern we are having here? A2 0, A3 1, 0 1 0 1. This is the pattern we are having here. Is that clear? Everyone? Is that clear? If anyone is still in doubt, you can ask. Okay, then that's better if you are able to understand. So this is what I received from the circuit of NAND gate. What I did in the NAND gate is this signal represents the CS bar, because what is entering inside the CS bar is totally dependent on these 6 inputs. If any one of them changes its state, the value of CS bar will be changing. So actually what we have done is we have created a circuit on which CS bar will be dependent. CS bar needs 0. It will be getting 0 in this circuit only when this configuration will be given to the NAND gate. Okay. So what next? Just next to A2 write A1 A0 selection lines, and what we know about selection line is there is a pattern of 2-bit that flows, and we have the selection. We already have a set selection, but what about this section? What should I write? So that section will have the same values which we have already created, because the circuit will remain as it is. Circuit will never change. Once it is connected, we have created a motherboard. It is not going to change the connections. The connections will remain as it is. Okay, so what we are just doing here, now look into the selection part. What we know already, that by having 0 0 in the selection line, what we are able to select is port A. Next we are having port B. Next we are having port C, and last we are having a CR. CR stands for your control register. Control register. Fine. So what we need to understand from this picture, we have an 8-bit pattern. Okay, so first convert this 8-bit pattern into the BCD. Convert this pattern into the BCD. Okay, so what we can see here, the BCD number what we are getting here is, what will be the BCD of this? Can anyone tell me? Can anyone tell me what BCD number I'll be having of the first one?
10, 10, 10.
No, there is no 10. 8 plus 2, it will be A. A8. So the first one will be A8H. Next one will be A9H. Then it will be AAH. Then next one will be ABH. This is what we are getting the BCD numbers after clubbing 4 bits on the LSB side and MSB side. So what these numbers are, what this information we are having here? Can anyone tell me what we have just found? We have just found the port addresses of the respective ports. Fine. So what is the address of port A? Port A's address is A8H. Port B's address is A9H. Port C's address is AAH, and the address of control register is ABH. This is what we understand by the port address. Fine. So what is the meaning of this? Now port A is having a valid physical and verified location A8, A9, A respectively for ports, and inside there is CR. CR is having A, B, H. Fine. So if this 8255 is connected in any circuit like this, like I've shown you earlier, like this, it is connected anywhere in this circuit, and the circuit wants to access the processor wants to access the ports. Suppose, let's say I draw here, this is my 8255, fine, and the processor wants to connect to port A or port B. So how the processor will connect to port A of 8255, port B of 8255, port C of 8255 or control register? Processor को वो पता होना चाहिए ना, processor must know where that location is. Fine. For in order to calculate that particular location, we designed a circuit. Fine. And after designing that circuit, what values of ports we have found is 8, A 9, AA and ABH. This means once they are connected in a closed circuit, by providing this command or this location as destination or source, you can access the port A simply because port A is now having a valid location. You can connect to the location by just taking this reference A8 or A9 or AA, just like that. Okay, but why I said three things: valid, physical, verified port address. Valid, physical, verified. There are three words you need to identify always. Is it valid? Is it valid? Is it physical? Have you verified it? We have done everything. Now look into this table. Look into this table. What we have done in this table? This table is having everything in the logical set category, which verifies all these words we are having here. Is it verified? Yes, it is verified. You can see from this table. Is it valid? This is particularly valid. You can see the sequence of the selection lines. This is definitely valid. Is it physical? Definitely it will be physical once we connect this circuit for the port map designing or port address designing. Okay, so let's do one more. Let's do one more because practice will make you understand things in a better way. So I take 8255 one more time, and you can simply draw port A, port B, port C, CR. Okay, the process is still same, that we need to take care of CS bar, but this time I'm not taking a NAND gate, this time I'm taking a simple AND gate. Okay, these are the selection lines. Okay, so A1, A1, A0, this is A2, A3, A4, A5, A6, A7. These are the lines from A2 to A7. In that case, tell me what will be the port addresses of port A, port B and port C along with control register. Tell me what will be the port addresses in this case. Quick. Quick. This is for all of you to attend. Just draw a table like this: A7, A6, A5, A4, A3, A2, A1 and A0. Fine. A0, A1 we know already. 0, 0, 0, 1, 1, 0, 1, 1. Selection we know already. Port A, port B, port C and control register. What will be coming at these bits A2 to A7? Can anyone tell me what is the objective here? What should we take care? What should we take care? What should come out as output? What should we take care? Can anyone tell me?
all should be 0.
The output of the gate should be 0. This is what we need to take care. The CS bar must be having the 0 input in order to select 8255. So how we are going to get 0 as the output of the gate? What will be the inputs? This is an AND gate. What will be the inputs here?
Sir, we must take at least one input as 0.
Okay, if you're confused with AND gate, let's make it NAND gate. Is it simple now? NAND gate is better. So now tell me the answer. What will be the port address of port A, port B, and port C? Shiv Tyagi, Akshaj, Rohit, Neeta, Rahul, Mayank, Kriti, Sanchita. Arpit, Badal, Deepti, Gaurav, Harsh. Anyone? Lalit, Mehak.
Sir, FC, FD,
Amit, no. You are not going to speak anymore. I want someone else to answer. Anyone else interested in giving the answer? Okay, then better. So in case of this C bar to be 0, the output of this NAND gate should also 0. So when the output of NAND gate will be 0, when all the inputs are 1, we have already seen they all should be 1. So we can simply put the values here, they all will be 1. Fine, we can again convert them into the BCD. And the port addresses can be generated. So in that case, the port address is, the first one is FCH, next is FDH, then FEH, and then FFH. So these are the port addresses of the port A, port B, port C, and control register of A to 55. So what are we going to do with this thing? Why do we need the port address? The question comes, what exactly are we going to do with the port addresses? Why? Why do we need port addresses actually? The exact question is this, why do we need them? Alright, so the point here is, in the last class we created a control word that was 91H in some configuration where I told you port A to be acting like input, port B to be acting like output, and something like this. So the value that what we have found was 91H as your control word. This is what we call control word, the contents of control register of 8255. Fine. So this thing is particularly in your notebook, but where do you want to load it? You want to load this particular value inside the control register of 8255, but you are not able to load this value until and unless you know the particular address where it is, where this particular control register is located. So somebody is just not able to load that particular value at that particular location. So that particular address needs to be designed, and it needs to be calculated, and then it needs to be connected via microprocessor. Right. So what we have just seen while designing this CS bar via some gate circuit like this, and what lines we were showing here, A2, A3, A4, A5, A6 and A7, these are the actual address lines coming from your microprocessor. This is the actual connection coming from microprocessor address bus A2, A3, A4, A5, A6 and A7. Fine. A0 and A1 is available already as selection line in the 8255. Fine. So processor will do what? Processor will do the selection by the help of, or with the help of, or via selection of these particular lines. It will load the particular value on these particular lines so that it can select port A, port B, port C respectively. So that's why we are particularly focused on providing a zero output to the NAND gate, or the zero input to the CS bar. So from where these A2 to A7 will be coming, they will be coming from the microprocessor. This is the actual connection from the microprocessor. Okay, so after that, suppose the processor wants to load this 91H. Okay, so let me draw it. So after port A, port B, this is your port A, port B, this is your port C, and this is the control register. It also needs an address. Like in the recent case, the address of the control register is FFH. So let's say this is your FFH, this was FC, FD, and this was FE. Okay, so processor wants to connect to FFH. Okay, so what commands am I going to write? So this side it is a microprocessor, but microprocessor is again having few things which needs to be connected. So what are those things we need to connect? One thing is the accumulator. Fine. So so how the overall process is, just note down. Once you calculate the value of this control word, that value will be loaded inside the accumulator. Then accumulator will out it to the particular location of CR, because CR के अंदर load करना है ना, the 91 should be loaded inside the CR. This is not the design for port A, port B or port C. We configured the control register. Okay, so what happens here is, what should I write as code? MVI, or you can also say move. This is an 8-bit code. Let's say AL, comma 91H. That's it. This means 91 will be loaded into the 8 bits of lower 8 bits of accumulator. After that, out, because we want to send it outside of microprocessor. This is going to out. So that will be driven by the command out. So out, the syntax of the out is out followed by the port address. Port address. So which port address are we looking for? We are looking for the port address of CR, control register. And what is the port address we are having? This is your FFH. So just simply write out FFH. Fine. So what will happen? The moment out is being executed, what out will see what is inside accumulator. Accumulator is having 91H, and that value will be outputted to the location in the hardware where the location FFH is created. So that 91H will be loaded into a location or the address where FFH is located. So simply this 91H from inside of microprocessor has been loaded inside the 8255 by using only these two commands. See how simple this is. The coding of interfacing is very simple, but in order to understand the concept, we need to do a lot of mathematics, lot of designing, concept understanding like this. You can see the Boolean work we have done in order to transfer the content from one place to another place. Coding is very fine. These are just two lines. You have to design the control word, move into the accumulator, out, port address, wherever you want. Fine. So this is the way you can actually load the command in the 8255. Is that clear? Okay then. So let's start with the input output modes of 8255. Okay, so in the operation of 8255, it works in three modes basically, and these modes are mode 0, mode 1 and mode 2. So what these modes are, let's study in detail. Mode 0 is simple input output, where nothing complicated in the configuration. We'll simply set something port A to input, port B to output, like we've already done a problem in the last class where I was asking you to configure port A as input, port B as output, port C lower, port C upper. That was actually the example of mode 0. So mode 0 is simply input output, where you will just place the value according to the configuration given. Simple input output. There is nothing complicated in this. Okay, so all the three ports in the mode 0, they all will act like the input output ports. All of them, port A, port B and port C. Okay, important one is this one, mode 1. You can mark it with writing important, or you can put a star, whatever it is. And this will be coming in the examination also. It is very important from the examination point of view. Mode 1. So what is in mode 1? In this, input output will be associated with some handshake. We have already studied about the handshake, strobe, IPF, OBF, ACK. So those signals which we have studied in the previous lectures, those signals will be employed in this mode 1. Okay, so what will happen in the mode 1? Port A and port B, they will be acting like the input output ports, but the port C bits, they will be utilized for the handshake. Okay, so whatever we have, strobe, IBF, AC, OBF, ACK, they will be traveling through the port C. Okay. Next is mode 2. Mode 2 is a bidirectional data bus for port A. That means it is a new mode which actually helps us in getting the bidirectional data transfer, but that is only for the port A. You cannot connect port B in the bidirectional mode. Fine. So port B can be either in the mode 0 or mode 1. Same port C bits can be used for handshake. So we'll see to it later, but first we'll start with the mode 1. Mode 1 again have two configurations, like for input control and for output, because there are two directions, input and output always. So we'll study separately for input and for output. So let's start with the input control in the mode 1. Okay, so I've already drawn the figure of 8255. This is your 8255 we are having here, and then I'll show you how the ports will be connected. Now the direction of the ports will be identified. Now you will not be getting the configuration like you have to set something in input or output, but you have to uh, learn from the, you have to guess it, you have to uh, get the information from the given figure. Okay, so let's draw few things in this particular figure. Okay, so this particular section will be of group A and this will be of group B. Fine. Since in mode 1 port C bits will be utilized for handshaking signals, so they will not be part of group A or group B both. They will be just randomly distributed between group A and group B. Fine. So let's draw this. Let's complete this figure. Now tell me, when I'm taking this input control, you can see by yourself I'm drawing something, and this is your port A. By looking at this picture, what you are guessing, what is the nature of port A? Is it acting like input or output? Tell me, what is the nature you are guessing from this? Is this port acting like input port or output port? Port A and port B, are they acting like input or output? Anyone?
Sir, output.
Sir, input.
Definitely, the direction is inwards. So there is no need to provide anything in the information. You will just have the figure, and you have to see from the figure that you have to configure port A as input. So that will be the definition you require in designing your control word, control register values. Okay, so now inside, if I give you the inside circuitry, there is very simple circuitry inside. There is only one AND gate inside 8255 in every group. This AND gate is having three inputs, and these three inputs are connected inside the 8255. Let me draw this. I could have shown you per full figure, but it is better to draw in front of you so that you can understand what these things are. Fine. So these three bits that I've just drawn, they are the bits of the port C. Fine. What is port C bits we are having here? PC3, PC4, not 4, 5. This one is 5 and this one is 4. Fine. So how these bits will be connected? These bits will be connected like this. They are the actually inputs of the AND gate. Fine. And where the output of the AND gate will be connected, it will be connected to the PC3. This is the simple connection we are having here. Now get back to the concepts of handshaking. What we have studied in the input time, we were having only two signals, and the third signal was INTR, which was required for interrupt the microprocessor. So what happens in this case? All right, let's try to understand by the concept of handshaking. So what we know, the first signal was strobe. STB was the first signal that we have just seen in the handshaking concept. So first signal that will be traveling inside from the peripheral, that will be your strobe. Since it is connected with group A, so just there will be a suffix, you have to write it like A. Fine. Only correction is this time it is active low. Fine. So strobe, you can write it like from peripheral. All right. So what we studied in the 8255, after receiving the ASCII code of that particular key that we have pressed, what 8255 will generate? 8255 will generate a signal which is called IBF suffix A. This is from 8255 to peripheral. To peripheral. All right. The third signal that was generated by 8255 was, it was a INTR, and it was for microprocessor after transferring the byte from one place to another place. for microprocessor. Okay, so let's understand the phenomena according to the circuit. So this is what we know. Firstly strobe, then IBF, then INTR. Okay, initially it is 0, it is active low, that means it will be having 0, but once it enters inside, it will be having 1 value. Inside the 8255 group A section, there are 3 inputs to this AND gate. One input is connected to strobe, one input, other input is connected to IBF, and the third one, which is inside, it is connected to, or it is called INTEA. What is INTEA? INT stands for interrupt enable. E stands for enable. Okay, so this is acting like an enable pin for activation of this particular AND gate. This will be activating this AND gate. Okay, so let's start in the sequence. What sequence we will be following? So first, how the process will start? The first one is, I'll be putting the number so that it could be better for you to understand. The first is strobe. Fine. So strobe will be giving the value 1. That means one input of AND gate will become 1. After that, your INTEA, it will become 1, since we have received one thing from outside, from peripheral. Now it will be the job of interrupt enable circuit to activate this AND gate. Fine. So second input is also 1. Now after receiving the pulses inside the 8255, or the data inside the input buffer of your 8255, so that third pulse will be generated by 8255. This is your IBF, so it will be again 1, the third input of your AND gate. So when all the inputs are 1 at AND gate, what happens in the AND gate? The output is all 1. Okay, so when now all the inputs are 1, this is the fourth signal, that will be INTR, and that will be generated for microprocessor. Okay, let me explain it again. First is strobe, second is INTA, then IBF, then finally INTR. So what is the ultimate objective here is, the ultimate objective here is to generate a pulse which is INTR. And what is INTR? INTR is the output of the AND gate. In order to get an output, all inputs of AND gate must be 1. So there will be a sequence that needs to be followed. The sequence is first strobe, it will be the middle input of the AND gate, then INTE second, then IBF third. Of if all of them are 1, then the output 4 will be generated, and INTR pulse will be sent to the microprocessor so that it can load the next, or the next operation can be initiated. Is that clear? Is that clear?
Yes, sir.
Just follow the sequence: strobe, INTE, IBF, INTR, that's it. It is just followed in the form of sequence. This is the ultimate you need to understand. Fine, and that thing will follow everywhere. The same phenomena will be here in the group B as well. Same AND gate. Fine. Output will be connected here. One input will be connected here. One input will be connected here, and one is here. Okay, so almost same circuit with different suffix INTE B this time. Okay, only the pins of the port C will be different. This is port C0, PC1, PC2. Okay, so what we have here is the first one, as you know, the first one is strobe B, then INTE B, second, third one, IBF, it will be sent outside, IBF B, and then finally when all the inputs are 1 of the AND gate, it will be sending a signal INTR B for microprocessor. So this is how this 8255's internal circuitry works. This is only single AND gate. All the inputs of AND gate should be 1 sequentially. Then you will be getting a 1 as output. Okay. So what we need to see here, what we need to understand few things here, that out of 8 pins of port C, how many pins we have in the port C? We have 8 pins in the port C. Out of 8, 6 have been utilized with the handshake. PC0, PC1, PC2, PC3, PC4, PC5. Okay. So out of 8, 6 have been utilized with these handshake. So what we are left with? We are left with 2 pins of port C. So what these pins are? 0, 1, 2, 3, 4, 5 used, but we are left with PC 6, 7. Fine. Since port C is still a port, so these 2 pins can still be used like an input output 2 pin input output 2 pin input output. Okay, so now everything is settled. We have port A connected in configuration, port C utilized with handshake. Okay, so this particular section is for group A with handshake, and this is for group B with handshake. Alright, so you will get a figure like this in your exam, and I'll be asking you to design the control word. Design the control word for mode 1 input configuration. Okay, so you simply need to draw the control word. A blank control word. Okay, and what we know about the configuration, at D0 we have port C lower. Now port C lower, look at the port C lower 0, 1, 2, 3. Port C lower is all occupied, so that will become don't care. Nothing to put in this. After this, D1 is your port B. Port B acting like what? Port B acting like input. So let's put 1. Which mode are we working in? Mode 1. D2, D3, group A, and this is port C upper, 4, 5 used, 6, 7 is still in the blank category, so you can use whatever it is, 1/0, whatever it is. You can use 1, 0, both will work. Because there are 2 pins which are still left. Port C upper half is still not used. D4 is port A, which is acting like input, and D5 and D6 for mode, which is 0, 1, mode 1, and D7 was 1, since we are talking about input output control word. Okay, so final word what will be coming out of it is 1, 0, 1, 1. If I take 0 here, it will be like this. You can also take 1 here, so there will be 2 values and both will be accepted, don't worry. If you finalize any one out of them, both will be accepted. So this is coming out 1011 is this is your B6 and this is BE. B6H or BEH, they both will be the correct answers, no problem. Okay, is that clear? Is that clear? Can you draw the control word from the figure? Just need to practice once and that can be done easily. It's nothing big in this. Okay, so input control, is that clear? Input control? Any doubt in there? Alright, then let's start with the output control. Almost same phenomena will be here. only the direction of ports will be different, and the signals that will be flowing in this 8255, they will be different. Okay, so how to draw the ports now? Earlier it was input, now they are output. Okay, so this is your port A and this is your port B. So in the output configuration, we had a write which will start the process, and same thing we are having here. Same AND gate because the IC is same. There will be three inputs here corresponding to the port C. Okay, so there is a slight change in the number of pins of port C now, because so it is PC0, PC1, PC2, then it is PC3, PC6, and then PC7. What we are left with, PC4, 5. They are still part of port C upper. Inside what we have, INTE A and then INTE B. Okay, so in this case, everything starts from this write. The processor will send the write command to the 8255, and the 8255, what will be the how the communication will start. The process 8255 having an input buffer, and via database the value or the command will be loaded into the output buffer of 8255. Okay, then 8255 will send a signal to the peripheral. What is that signal? That signal was OBF A, output buffer full. Okay, that was a signal for the output peripheral like printer or monitor or something. Okay, then the peripheral sends a signal back. What was that signal? The signal was ACK, acknowledge A, that is from peripheral. Fine, and the final signal that was generated, that will be generated, is again the INTR pulse for your microprocessor. So the next byte can be written or it can be loaded. All right, so this is how this operation is. Now go inside, let's go inside and try to understand the sequence now. So first is by the writing, the command will be loaded here at this point of time. After that, the 8255 will send a signal which is called OBF. So OBF is the first one which will be coming. So that is the middle input of AND gate. After that, we are receiving something from the peripheral. So we are having this signal from outside. Okay. Now tell me the sequence when INTA should be active. INTEA should be active. When it will be active? When INTEA should be active. Because this OBF is generated from inside. When INTA, when it will become 1 or it will become active? Anyone? You can correspond to the previous example or like what we have studied in the input configuration. Take reference from this. What INT is doing in this, we received the first signal from a strobe from peripheral, right? So that signal was sensed inside. Then after, the second was INTA. So what INTA is following, just try to understand the concept here. What INTA is following, it is following the input from the peripheral. Okay, input side it came earlier, but in the output side it is coming a little later. The first signal is generating from 8255 itself. Now the second signal that will be coming is from peripheral. So what it will be doing, the second is from peripheral, and after that INTEA will be active. So it will be sensing the same algorithm. It is dependent on the input from the peripheral. So first the input from the peripheral will be coming. This is the first input of AND gate. Then INTE will be active. That will be the third input. Once the all inputs are 1, the output of AND gate will become 1 and it will generate the INTR pulse for the microprocessor. Okay, just a little change. What INTE follows the input from peripheral. You just need to note down this thing. So that sequence will be maintained by you. Okay, now the sequence here is first one is OBF, then ACK, then INTA, then finally PC4 INTR. Okay, so that was for your group A. Same thing exactly will be followed for group B, OBF, B, then ACKB, then INTR. Same phenomena. All right. So again, I'll be asking you to design the control word for this. So just draw an empty control word. So let's find out how these values can fit inside, and we could be able to design the control word. So what is the D0? D0 is the port C lower part. Port C lower, let's see where are they. PC0, PC1, PC2, PC3. It is all employed again. So don't care, it will become port B. Port B, D1 is port B. Port B acting like output. Output means 0. D2 is mode. Which mode we are working? 1. D3 is again port C upper part. For 2 pins of port C upper are still unused. So you can configure them accordingly. 1 or 0 if you want to use them sometime. So D4 is what? Major port, which is port A of group A, that is acting like output. D5 and D6 for mode 1, 0, 1 it will be, and D7 is 1 since we are in input output. So if again I have to write the control word, it will become like this. So this is what? This is your ACH and this is your A4H. Both of them are fine. You can give me any value for control word. Okay, is that clear? Input control word and output control word.
Yes, sir.
Is that clear?
Yes,
Everyone?
sir.
It's very easy. It may look like a little tough, but it is not tough. You just need a little practice. That's it. Okay, and the book you need to follow for this one is better book is RS Gaonkar. For interfacing ICs, the book I recommend is RS Gaonkar. And this particular thing, if I have to write it down, handshake signals are given at page number 460 and 461 in RS Gaonkar, and this 8255 is starting from yes, no, the 8255 is starting from 460 onwards, and handshaking signals are at 4. Let me check. They are at 430. Handshake signals are at 430 and 31. And 8255 starts from 460. Fine. All of these details you can find, and they are written in quite detailed form. You can follow that book. It is very good book. Okay then. So this completes your 8255. We'll do some more questions in tutorial. I'll give you one full-fledged tutorial of this 8255 and 8254 once 8254 is complete.